the mean. So again, when we look at a distribution or a density function, sometimes we really want to find out what's happening on average. So one way that we can talk about the average of a distribution is called the mean. You may have done this in other classes. The mean of a distribution is the average of all possible outcomes. So sometimes in other courses, this is called expected value. So if we were to have something that was weighted, it can be shown that the mean is the point on the horizontal axis where the region under the graph of the density function, if it was made out of cardboard, would balance. So the mean is equal to taking every possible outcome and weighting it by its probability, and then averaging those over all possibilities. So we're taking each value of x, multiplying it by the probability that it happens, or the fraction of time that it happens, and then summing those all together. And so we can do this sum by using the integral. So when we want to calculate the mean, we're going to do x times p of x. So our density function times x to represent every possible value, and we're going to integrate that over the bounds where our PDF exists. So here we write it from negative infinity to infinity. In practice, we're going to use the bounds that are given to us in the problem. So for all of these, we're going to be doing a definite integral, which means that a lot of our work is just making sure that our integral is set up correctly to calculate the mean. Now, if we're given bounds on our integral, the mean should fall within those bounds. If it doesn't, then we've calculated something incorrectly. So let's see how this works. Example 1. Suppose the probability density function is given by, we have 3x squared when x is between 0 and 1, and 0 otherwise. So it only exists between 0 and 1. We want to calculate the mean. So remember, to calculate the mean, we're going to integrate over the entire bounds where our function exists. So that's going to be from 0 to 1, and we're going to do x times our density function, which here is 3x squared dx. So I'm going to simplify this a little before I calculate. So the integral from 0 to 1, I have an x and an x squared, so I will make that x cubed. So now, since this is a definite integral, I can plug this into my calculator. I could do it by hand if I wanted to, but I'm going to use my calculator here. And when I plug that in, I'm going to get x equals 0.75. I want to make sure that it's on my interval, which is 0 to 1, so I'm all set. So the mean here of this distribution, the average value, is 0.75. So again, I'm multiplying x times my density function to get my mean. Let's look at another. Example 2. Given the density function below, find the mean. So here I just have a picture, and I know that the area under this triangle is 1, because if I do 1/2 base times height, I get 1. And so I need to find the equation of this line so that I have my density function. So again, if I have a line, I need 2 points on my line. So the first point is 0, 2, and the second point is 1, 0. To get the slope of the line, I'm going to do change in y over change in x. So 0 minus 2 over 1 minus 0 gives me a slope of negative 2. I know my b-intercept is where my line crosses the vertical axis, so that happens at 2. So that gives me a density function of negative 2x plus 2. So now that I have my density function, if I want to find the mean, the average value of all the weighted possibilities here, I need to integrate my function over the bounds. So from here, that is 0 to 1 of x times my density function. So negative 2x plus 2 dx. I'm going to simplify this before I calculate. So I'm going to distribute the x through, and I get negative 2x squared plus 2x dx. Now this is a definite integral. There's two numbers on the bounds, so I can either do this by hand or I can plug it right into my calculator. So if I plug it in, I'm going to get 0.33 repeating. So I'm going to round to two decimal places, 0.33. So the mean of this distribution is 0.33. Again, that falls on my bounds. My bounds are 0 to 1, so that's excellent, because if it was not on my bounds, then that would mean I calculated something wrong. And so that tells me, again, the mean of this distribution. Let's look at the next example. Example 3. A quantity Q is distributed with a density function of P of x equals 0.5 times 2 minus x for x between 0 and 2. The probability is 0 otherwise. We want to find the mean of this distribution. So again, in order to find the mean, we have to properly set up our integral. So our integral here is going to go from 0 to 2, because those are the bounds of integration that we were given. And then we have x times our density function, so 0.5 times 2 minus x dx. So we have to be a little bit careful when simplifying here. So first I'm going to multiply through the 0.5, and then I'll come back and multiply through the x. So if I multiply half times 2, I'm going to get 1 minus. Now 0.5 times x is 1/2 x, or you can write it as 0.5x, either is fine. And now I'm going to multiply the x through. So I have the integral from 0 to 2 of x minus 1/2 x squared dx. And again, this is a definite integral, so I can plug this into my calculator. So when I plug this in, I get 0.6 repeating, so rounded to two decimal places. I get 0.67. So again, the average of all the weighted values on this distribution give us a mean of 0.67. Let's try one more. Example 4. Let P of t equal negative 0.0360 t squared plus 0.221 t be the density function for the shelf life of a brand of banana which lasts up to 4 weeks. Time t is measured in weeks, and t can take on values between 0 and 4. We want to draw the density function and label the mean value. So I've graphed the function here. We said that time is going to be in weeks. So the probability that the banana is still good is given on the vertical axis. So we're looking for the mean time that a banana has a shelf life, so how long it stays good for. So again, when we're calculating the mean, we're taking the average of all possible values to figure out which is most likely. So what's happening here is we set up our integral over the bounds from 0 to 4. Our variable here is t, so we're going to do t times our density function, so negative 0.0360 t squared plus 0.221 t dt. We'll distribute the t through, so we'll have negative 0.0360 t cubed plus 0.221 t squared dt. And when you plug that into the calculator and you use your bounds 0 to 4, you're going to get a mean shelf life of 2.41 weeks. So 2 is here, 3 is here. It's a little bit less than half between. A little bit over here, this is 2.5. So 2.41 is here. So this is our mean. So again, the mean is going to give us a measure of central tendency or expected value. The disadvantage of the mean is that it's more sensitive to outliers. If something is skewed really high on one end or really low, it's not as reliable as, say, the median. but it is helpful in determining different measures that tell us the average in a different way of a distribution.